Did you know that vaccines help keep us healthy by triggering our immune response to a harmless or inactive version of a dangerous pathogen? And the immune response. So, like we've talked about before, capillaries are extremely small blood vessels where only one red blood cell can travel through at a time, and they're only one cell wall thick. This allows nutrients, gases, and other components to move out of the bloodstream and into the body tissues, and from the body tissues into the bloodstream. The lymphatic system intermingles with the capillary beds because some of the plasma will escape from the capillaries due to pressure and become part of the interstitial fluid. So, this is fluid that fills the space between our body cells. It bathes our cells in plasma, allowing again water and nutrients to transfer in and out that's contained in the plasma, and wastes and carbon dioxide to filter out of the cells into the lymph system. So rather than re-entering the circulatory system at that site, lots of the interstitial fluid drains into the lymphatic system. And it's a clear yellowish fluid similar to plasma, and it's known as lymph. Lymphatic vessels are similar to veins because they use the contractions of our body muscles to move the lymph back through them. And the valves are going to, again, prevent that backflow. We have lymph nodes located at different intervals along our lymph vessels that contain macrophages and lymphocytes, which help trap and destroy other bacteria that's in our lymph system. And when you get sick, your lymph nodes in your neck, possibly your groins, possibly your armpit, may swell because of the increase of macrophages and lymphocytes in that system. So here's a diagram of the lymphatic system. So it's showing our thymus gland near our heart. We have our tonsils are part of our lymphatic system. We have lymph nodes in our groin and our armpit, as well as the spleen helps remove damaged blood cells and microorganisms from the blood. Now, looking at the body's defense system, our body wants to protect itself from anything in the environment that could be potentially harmful. And these are called pathogens, which comes from the Greek to mean producer of suffering. So the human body must defend itself against the constant attack of pathogens by one, preventing them from entering the body, and two, destroying the pathogens if they do enter the body. Our first line of defense is to prevent pathogens from entering the body. So these are called physical defenses. So it's things like we have a slightly acidic, dry skin, where we have oily secretions that contain antimicrobial agents. We have hair, our eyelashes, our hairs in our nose that help trap things that might enter. We have an acidic stomach, mucus that traps potential pathogens, earwax, and tears. Our body's second line of defense is non-specific defenses. So this occurs anytime our body cells are damaged. So the tissue cells that are damaged release chemicals that initiate an inflammatory response. So this could happen if you have a bee sting, if you have a sliver, or if you have a localized infection. So this condition can result in increased blood flow to the area. So because of that, the area might feel warm, red, and we might have swelling in that area because of the increased blood flow and the increased white blood cells that are traveling through that area. If we have a bleed, we might have increased blood flow to help with clotting. And our body also creates heat in the form of a fever because lots of bacteria and microorganisms can't live successfully or replicate successfully at a higher temperature. So that fever helps our immune system destroy any pathogens. So the inflammatory response begins when a blood vessel is damaged, and it releases chemicals called histamines. So histamines cause swelling in that injured area and attract monocytes, which is a special type of white blood cell. They turn into macrophages, which stands for big eater. So they'll completely engulf any bacteria that are in that area, which are then going to neutralize and destroy them. Other white blood cells known as neutrophils, which are also macrophages, are going to release digestive enzymes to destroy that invader. And the remainder of the invader and the macrophages is called pus. So that's what we see after we have a cut that might have had a little bit of an infection. So looking at the inflammatory response, we can see there that we have that tear in our blood vessel. We might have some nerve pain, the histamines that are going to cause an inflammation response, and then our neutrophils and monocytes, which are going to engulf and destroy the bacterial invaders. So here's a macrophage action, gathering pathogens to engulf and destroy them. So our third line of defense is known as the immune response. And this begins after a pathogen has been destroyed. So one of our body cells has to have destroyed a pathogen before the immune response can begin. So all cells from our body and from outside of our body have special markers located on their cell membranes. These are known as antigens. So they identify what type of cell it is and what it might belong to. And typically our body does not react to our own antigen markers. Antigens, again, are going to be found on the surface of cells, on human cells, and on pathogens, and they identify the type of cell that exists. For our specific immune response, we have two different lymphocytes found in the immune system. We have T cells and B cells. T cells are lymphocytes. They mature in the thymus gland, located near the heart. They're going to seek out invaders that have antigen markers that don't match the body's own markers. So T cells are going to look for cells in our body that have antigens that are different from our own antigens. There are several different types of T cells. We have helper T cells. So after a macrophage engulfs an invader, that invader's antigen markers are then going to be displayed on that macrophage. The helper T cells then are going to stimulate the production of other immune cells by producing a chemical messenger called lymphokine. We have killer T cells, which are cytotoxic. They bind with our infected cells and destroy them by puncturing their cell membrane. So this kills bacteria, fungus, protozoas, and even cells that are infected with viruses. So killer T cells, to get rid of the infection, end up killing our own body cells. We then have suppressor T cells, which slow and suppress the immune response by inhibiting the B cells. So this happens after an infection has occurred and our body has successfully fought it off. The suppressor T cells are then going to reduce our immune response so that our system can go back to homeostasis. And lastly, we have memory T cells, which remain in the bloodstream and are able to react quickly if that specific antigen is ever encountered again. So here we have our helper T cell says, oh look, something new has come into our body and it shouldn't be there. So then our helper B cell with the antibody comes and attaches itself. It says, here, I'm going to make this antibody that's going to attach itself to all the invaders. Then the macrophage is going to engulf that pathogen with the antibodies attached to it. And the cytotoxic T cell is going to destroy that cell and the pathogen within it. So B cells are activated by helper T cells. They produce proteins called antibodies. So antibodies are proteins that protect against foreign invaders, viruses, or cells because they recognize specific particles due to their shape. They recognize those foreign shapes, and so that's useful in defending against foreign invaders. So typically we have antibodies for diseases that we've either had before or have been vaccinated against. Antigens are molecules that antibodies are capable of recognizing. So we have antibodies in our system for all the different antigens that would have been on any pathogens that we have come in contact with and then fought off or been vaccinated against. So the body can recognize different bacteria and viruses as being foreign because they have antigens that are different than our body's own antigens. Antibodies typically are Y-shaped molecules with two binding sites. They fit together with the antigens like a lock and key. And the body doesn't produce any antibodies that binds to its own cells. Therefore, all the particles that are bound to antibodies are foreign. And we have these Y markers because then it allows the antibodies to collect many antigens together, to clump them up, to make them easier for macrophages to destroy. So cells and particles or molecules that are marked with antibodies may be phagocytized by neutrophils or macrophages. So there we can see how the antibodies will collect many pathogens together by attaching to their antigens, making it easier for the macrophage to engulf several or many at one time. This is known as agglutinating or clumping together. So because each antibody is capable of binding to two antigens, they clumped together and then they are phagocytized. So, in our immune response, the skin is broken and the inflammatory response is initiated. And this is a general, so it's not a specific immune response to any specific antigen. So, non phagocytic leukocytes release histamines, which cause inflammation and increase blood flow to the site. Macrophages are then going to engulf the bacteria, incorporate and display the antigens on their cell membranes. Helper T cells are going to bind to those foreign antigens and make a copy, which are then going to activate the B cells. B cells make antibodies which attach to invaders and help to stop the infection. Killer T cells seek out and destroy invaders that are marked with the antibodies. Memory cells keep a copy of the invader's antigen so that it is ever encountered again, the immune response can be initiated much more quickly. Thanks for joining us today, and I'll catch you guys again next time. Bye.